Okay, listos. All right. So everybody should have their study guide, and Joaquin is back to his desk, and everybody's ready to continue with the study guide. You guys have been working on it. Me and Divine have the study guide out. Yeah. Okay. Thank you. All right. All right. Now, number 6 is a beautiful system of equation with 3 variables. If you guys remember how to do systems of equations, we basically can solve either by graphing, eliminating, or substituting. It's all up to us how we want to proceed. However, whenever we have 3 variables, the easiest step is to do elimination. Now, whenever we proceed with elimination, we have to make sure we identify the number of equations that we have. So we have 1, 2, and 3. So I'm going to go ahead and label them as 1, 2, and 3. This is my equation 1, my equation 2, and my equation number 3. Woo! Look at that, how beautiful. All right. Now, from here, we're going to go ahead and combine 2 equations in order for us to eliminate 1 variable. So our choice is ours. What equations do you guys want to do? 1 and 2? Okay, perfect. So I'm going to go ahead and do 1 and 2 right here. My writing super tiny. So I'm going to go ahead and write 1, 2x plus 3y plus z equals 27. My second equation is x plus 5y minus 3z equals 52. Now, from here, we have to identify the variable that we want to eliminate. Doesn't matter which one we choose. No, it does not, as long as we do it properly. Now, in order for us to eliminate a variable, we have to have same number, different signs, or opposite signs. So in this case, I'm going to go ahead and choose my x's. I have 2x and x. What do I need to multiply equation number 2 so that it can become a negative 2x? We're going to go ahead and multiply it by negative 2. Okay, perfect. So let's go ahead and rewrite my first equation. We have 2x plus 3y plus z equals 27. I have now negative 2x minus 10y plus negative 2 times negative 3 is positive 6z equals 52 times 2, negative 104. Okay. Now we can go ahead and combine. What happens to my beautiful x's? They go to 0. They eliminate. So what are we left with? 7y, negative 7y, and 7z equals 127 minus 104, negative 77. Okay, I'm going to go ahead and have these 2 variables now, y and z. I'm going to label this equation number 4. All right. Now I have to do another combination of equations. I picked 1 and 2. I either have to do 1 and 3 or 2 and 3. Which ones do you guys want to do? 2 and 3, since we have to eliminate the same variable? Yeah. Okay. All right. So let's go ahead and do 2 and 3. So number 2, it's x plus 5y minus 3z equals 52. 3 is negative 3x plus y plus 2z equals negative 16. All right, what variable do we have to eliminate? We have to eliminate. We have to eliminate x. Why? Because we eliminated x in the first combination of equations. So let's see, we have to multiply the first equation by, if it's negative 3, our opposite coefficient would be positive 3. Okay, so we have now positive 3x, 5 times 3, positive 15y, 3 times negative 3, negative 9z, and 3 times 52, 150. 56. Minus 3x plus y plus 2z equals negative 16. All right, what happens to my x's? Woo! They eliminate. Look at that. Okay, what am I left with? What do I have left over, guys? 16y minus 7z equals 140. There you go, 140. What am I going to label this equation? I'm going to label it number 5. Okay, what do I do with these equations now? 4 and 5. I create my little mini system of equations. So I have 4 and 5 this time. So I have negative 7y plus 7z equals negative 77. 16y minus 7z, bless you, equals 140. All right. Do I have any variable that have the same number, coefficient, opposite signs? 7 z's. So these two are going to combine. They go to 0. And we're left with 9y equals negative 77 plus 40, 140? 63. We have a 1-step equation. Divide by 9, y equals, that's 6, 7. Woohoo. So y equals 7. From here, we're going to go ahead and check out which one has y. For the value of 7, we already see that it's B, but let's go ahead and double check. Let's go ahead and double check and see if we actually do get 5 and negative 4 as my other solutions. Now, how do I find my other values, guys? How do I find the other values? Go back and substitute. Which one are we using? 1, 2, 3, 4, or 5? Which equation do I use next, Joaquin? For if we use 2, we need x, y, and z. I only have y. So we use either 4 or 5. So you guys want to use 4. So if I use 4, negative 7, I'm going to substitute what? 7 plus z. 7z equals negative 77. So many 7s. This gives me negative 49 plus 7z equals negative 77. 49. What do I do next, guys? To the two-step equation? Add 49 on both sides. I'm left with 7z equals negative 28. Divide by 7, and I'm left with z equals negative 4. So I have my z. Now I have to show my work for our x value. Which equation am I going to use next? Now we can use number 2. Can I use any of the other 2? Yes, you can. However, it's your choice. They should all give you the second solution. So if I pick number 2, I should have x plus 5 times y. We said y was 7. Minus 3. Z, we said it was negative 4. And it is equal to 52. So we have x plus 5 times 7 is 35. Negative 3 times negative 4, positive 12 equals 52. 35 plus 12. 47. There you go. It's okay. 1-step equation. Subtract 47 on both sides. We're left with x equals beautiful 5. And that's where we get all of our solutions. And if we were to write our beautiful coordinates, remember that it's x first. So we have 5. Then it's y. So we have 7. And the last one is negative 4. Woohoo! So this one's B. Not too bad, right? So again, whenever you guys see this example, you can do the same following procedure. Find the variable that you want to eliminate first. Then eliminate the same variable in your second set of equations. So for example, I have 1 and 2. I eliminated x. Then I did 2 and 3. I have to eliminate the same exact variable. The reason being is because I'm going to go ahead and create equations 4 and 5. From there, I'm going to go ahead and eliminate another variable. And I should be left with one variable equation, okay? When I do my combinations. And double check your work. Sometimes your multiplications or your distribution of numbers have to be nice and beautifully done, okay? All right, listos. All right, number 7. This one we have another system of equation. Yes, we can go ahead and check our work by solving. We can go ahead and check our work by graphing. And we can go ahead and identify how many solutions we have through that, okay? So in this case, since we have a system, we're either gonna have 2 points. We can go ahead and have 1 point or no points at all. It all depends where the positions of the graphs are. Now, let's go ahead and do by graphing first, and then we're gonna go ahead and double check by doing it mathematically. Go ahead and go past. So my first equation is y equals 2x plus 5. What is the parent function for this beautiful equation? It should be what kind of a line? Quadratic, a square root, a cubic, a linear, a what? What does it look like? What's my power? Power of 1, so it should be what? Y equals mx plus b. It should be a line. Anytime you have a power of 1, you're going to have a line as a graph. So let's go ahead and graph it using my slope-intercept form. So in this case, I'm going to go ahead and start with my b. My b is on what? On my y-axis at 5. So here's my beautiful graph. Now, from here, I'm going to go ahead and continue on with my slope. What's my slope? 2 over 1. Whenever we do our slope, we do run over or rise over run. So we're going to go and rise 2 steps and we're going to run to the right. So we're going to draw the next point, up 2 steps, 1 to the right, up 2 steps, 1 to the right. Now, if we happen to run out of space, we can go the opposite direction from our y-intercept. We can go down 2 spaces, but instead of going to the right, we go left. So down 2 spaces and left. We need to follow that linear pattern, that line. We have to do a straight line, just how whenever you line up in order. So we need to create that line nicely and beautifully done. And there you go. So let me go ahead and draw this very quickly. Here's my beautiful line. Look at that, beautiful. All right, ready for the next one? Now, that was my line. No, next equation. Yes. ¿Ah? ¿De dónde salió el 1? Es el slope. Cuando no tiene, whenever it doesn't have a denominator, automatically es 1. Okay, listos. All right, now the next part, how do we graph the following equation? Y equals, inside parentheses, x plus 3 squared minus 4. Now, whenever we had transformations, we were able to identify the parameters that were given. Let me go ahead and write the general form. G of x equals our a, x minus h squared minus, or plus in this case, k. Let me go ahead and write the equation that we're given here today. Right underneath. Instead of saying g of x, we had given y. We have x plus 3 squared minus 4. Now we had different parameters. Do you guys remember what this parameter does? H. Can you guys recall? What does my H parameter do? My K moves it up and down. That one goes up, left and right. So my K parameter moves it up, down. My H parameter moves it up or down, left or right. My A is going to either stretch it or compress it vertically. So this one is a stretch or compress. Okay. Now, do we have an A parameter? It's 1, so it doesn't do anything to it. The next parameter that we have is H. In this case, my H is negative H equals what? Not 2. What is my H? My H equals 3. So let's go ahead and simplify H. Divide by negative 1. We're left with H equals negative 3. So how many steps are we moving? 3 to the what? It's negative, so it's to the left. My next parameter is K. This one moves it up or down. K in this case equals negative 4. So therefore we're moving up or down? Down 3. I mean down 4. So we're moving down 4 and 3 to the left. Okay. Now let's go ahead and construct the points for our beautiful parent function. Do you guys remember the domain that we used? Negative 2. What's my next value? Negative 1, 0, 1, and 2. Here's my X. Here's my Y value. All right. What happens here? What's my parent function? X squared. So my Y is X squared. So let's go ahead and see. Negative 2 to the power 2 is 4. Negative 1 to the power of 2 is 1. 0 to the power of 2 is 0. 1 to the power of 2 is 1. And 2 to the power of 2 is beautiful 4. Let's go ahead and graph the parent function first and then transform it. So 0, 0, 1, 1, 2, positive 4. Let's go ahead and add another value. If it's 3, my Y value should be what? 3 squared is 9. Woo! Okay, let's go ahead and do the next one. Negative 1, 1, negative 2, positive 4, and the last one, negative 3, positive 9. All right. These points that I drew are not my actual function. This is the parent function. Each of those points, I'm going to transform them according to the parameters. So what are these steps that we're going to take? We're going to go 3 left and 4 down. So each point, 3 left, 1, 2, 3, and 4 down. 1, 2, 3, 4. Okay, I did this one. My next one, 3 left, 1, 2, 3, and 4 down. 1, 2, 3, and 4. I did this one. My next one, 3 left, 1, 2, 3, and 4 down. 1, 2, 3, 4. I already have a repeated point, so this one's check. My beautiful point here, 3 left, 1, 2, 3, and 4 down. 1, 2, 3, 4. Check. My next point, 3 down or 3 left? What are we moving, guys? 3 left. 1, 2, 3, and 4 down. 1, 2, 3, and 4. This one, check. 3 left. 1, 2, 3, and 4 down. 1, 2, 3, 4. And the last one, 1, 2, 3, and 4 down. 1, 2, 3, and 4. There you go. So I should have a graph that looks like this. Beautiful. The graph. The graphs and your transformations. Identify your transformations, and if you need to have your parent function points, go ahead. But I need to see the transformation. So I need to see your parent function and then it being transformed, showing where they intersect. So what are my points that they intersect? They intersect at -4, -4, -3, and my second point was at 0, +5. So my answer is D. It says by graphing, you can go ahead and do it mathematically just to check your work. Let's see. Okay, how do you feel about this one? Let's see if you guys recall the transformations. Let's see this one. G of x equals x plus 4 squared plus 2. How did this one move? Go ahead, Emma. This one is what? Right. It's going to the, not the right. If it's plus, it's going to go left. So this one is moving left. How many spaces? 4, and it's going up. How many spaces? 2. Okay, let's go and do another one. G of x. Let's go and do this one. X. Let's do -16 squared minus 16. All right, what about this one, guys? How is this one moving? Okay, let's do this parameter right here. So it's negative, so it's moving to the right, 16. And up or down, how many spaces? It's moving down how many spaces? Down 16. Otro, porque no me contestan. Let's see. G of x equals x minus 1 squared minus 2. How's this one moving? To the right 1 and then down 2. How do I know, Ms. Vasquez, if I'm going left or right? Now, remember that my h is negative. Whatever value that's in here, it's going to always be the opposite of that. So let's say that I have right here in this case, negative h equals -1. If I go through the procedure and I divide by -1, I have h equals +1. So the value of h is positive. However, whenever it goes into the equation, it's the opposite value of that. So if h is positive, it goes to the right. If h is negative, it goes to the left. Inside of my equation, if h is negative, it goes to the right. If h is positive, then it goes to the left. Okay, so just keep that in mind. It's a little confusing, but just make yourself some notes. Okay. All right, let's go ahead and do our transformation. Woo, look at this one. Write a function that transforms our beautiful parent function, f of x equals x to the power of 3 by a vertical stretch of factor of 2, shift 4 units left, and shift 3 units down. Now, without looking at our options, let's go ahead and clear them out for a little bit. Don't even look at your options. Say that. I don't want to know what they are. Así, mira. Woo, they're blanked out. Perfect. Okay. We're going to go ahead and look at the parameters that are given. All right. Let's go ahead and write our general form. Here's my general transformation. A, x minus h plus k. Something is missing. What's missing, guys? Power of 3. Where does it go? After the second parenthesis, so power of 3. So this time I have f of x equals x to the power of 3. Now let's go ahead and identify my parameter. My first parameter is a vertical stretch of 2. My second parameter is a shift 4 units to the left. And my third parameter is shift 3 units to the down. Okay, now let's go ahead and identify our parameters. Which one's which, guys? So our factor that stretches it vertically is going to be A. So A in this case is equal to 2. Now this one, what parameter is this one? This one is H. Either left or right is going to be H. H in this case is 4. Now it is left. So if we move to the left, it's going to be negative. In the equation, it's going to be positive. But as we identify H, it's going to be negative. Plus you. And 3 shifts, 3 units down. This one's going to be K. K is what? Negative 3. So let's go ahead and substitute our values. G of x equals 2x minus negative 4 to the power of 3 plus K is what? Negative 3. All right, let's go ahead and simplify. G of x equals 2. Negative and negative give me positive 4 to the power of 3 minus 3. Woohoo! Make sure that whenever you guys find your solution, some of you guys do the work correctly, you guys select the wrong one. I hate when that happens. It breaks my heart. So carefully go through your selection or your possible solutions and select the correct one, guys. I mean, which one is it, guys? It was D? You sure? Yes. I mean, let me bring it back. I'm bringing it back, guys. There you go. Your solution is D. Make sure you check your options. Así, mira, check your options. What time is it? Do we still have time? Yeah. Ready for the next one? I'm only going to do 2 more, and I think we're done for today. You guys need a brain break. Okay, listos? Yeah, everybody has this? Okay, clear. All right. Now, this one, guys, I'm going to go ahead and show you guys how to find the general form of polynomial equations. This is when we had our beautiful posters. You guys remember the posters? Yes. Yes, Ms. Huskus. Okay, perfect. All right, before I even go to this example, I'm going to go and show you guys the general form. Now, there's 2 different types of functions that we had. We had an even function and an odd function. And within those 2 particular functions, we had some with a positive coefficient, some with a negative coefficient. So I'm going to go ahead and draw my 4 possibilities so you guys can see it. So somewhere in your paper, go ahead and draw this somewhere, guys, somewhere in there. So you guys can have it as like a cheat sheet or somewhere, something to guide yourselves with, okay? Now, my first type of function that I had was x to the power of an even number. That was, for example, x to the power of 2, x to the power of 4, x to the power of 6, or x to the power of anything that had x to the power of an even number. Okay. Now, how do those graphs look like? Well, let me go ahead and construct my little graph. And I'm going to focus on the end behavior. Now, we said that whenever we had x to the power 2, both of our end solutions or our end behaviors were both up. So they had to go up and up. Therefore, I'm going to have an equation that goes up crosses however many times it needs to cross my x-axis, and it's going to go up. Some of them are going to look like that. Some of them are going to look differently. It depends on how many times it crosses through my beautiful axis, okay? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. Now, my end behaviors are what I need to focus on. On my left side, it goes up. On my right side, it goes up. Okay, that's all I'm looking for. My next type of function that I had was anything with my odd exponent. These are examples like x to the power 3, x to the power 5, x to the power 7, and so on and so forth, until I had x to a power of an odd number. Anything with the power of an odd number. Now, let me go ahead and draw these possible cases. Now, this one, on the left side of my x-axis, it came from the bottom, and on the right side, it went up. So somehow, somewhere in between, it crossed the x-axis so many times. 1, 2, 3, 4. And let's go ahead and say it crossed 5 times. There you go. So many times that it created this behavior. On the left side, it went down. On the right side, it goes what? Up. Okay. Now everybody's copying this down, guys?
Yes.
Okay. Now, what happens whenever we had a negative coefficient? Let's go ahead and say that I have negative x to the even power. What happened to my end behaviors? For a positive coefficient, guys, they both went up. What happens when it was negative? They both go what? Down. So I'm going to go ahead and have my beautiful equation somehow go 1, 2, 3, 4, 5, and 6. There you go. They both go down. How do I know? Because they both go down. So therefore my coefficient must be negative. And the same thing happens with our beautiful odd. So here's my odd. Guys, focus, please. And this is negative x to the power of an odd number or an odd exponent. Instead of coming from the bottom, it's going to come from the top. And on my right side, instead of going up, it's going to go down. So what happens to my both end behaviors? They're going to go ahead and flip. So 1, 2, 3, and 5. Woo, woo. And again, my end behaviors flip. All right. Okay. Even behavior, guys, both go up. Negative coefficient, even behavior, both go down. Odd behavior, it comes from the left down and it goes up on the right. Negative exponent, negative coefficient, they flip. So they come from the top and they go all the way down. All right. Now let's go ahead and analyze what's given. Let's go back to our equation, this one right here. Número 9. Says right here, which is a graph of an even function with a positive leading coefficient. So what are we looking for? We're looking for what type of end behavior if it's even? Both end behaviors have to be up and it's positive, so therefore they're both facing up. So which one has both end behaviors up? This one has down, up. This one has up, down. This one has up, up, and this one has down, down. So it has to be B in this case. A, let's go ahead and analyze A. What is A? And this one is odd, positive. This one is odd, negative. And this one is negative, even. And this one is positive, even as well. How do you feel about these guys? Okay, much better?